Good morning, Brandon. This is for you.
4, 3,
So special
2,
show for you
5.
today. We have been studying projectile motion, and what that is, we need to review for Alex has been out for a little bit, Hunter. So let's review for them. So what I would like you to do you have this sheet as well? I think I gave it to you. I have another.
Is it like the day whatever notes?
The
Day
one
2?
I'm pointing to now would be day 2.
Okay.
You
Yeah,
got
I
that?
have this.
All right, would you get as much of this down as you can? I'm going to be going quickly, so just get what you can. All right, I need to be quiet so that we can review quickly. The projectile motion was when we were launching an object, and the only thing acting on it is what, Emily? Number 3. Right. When you launch a projectile, of course there's some force that launches it, but once it leaves the launcher, whatever the launcher is, your arm or the barrel of a gun, whatever, nothing is acting on it anymore except gravity, and it will follow this path. It's called a parabola. Now, I put it in white. Can you see the white kind of blended in with the yellow? Here's the path of the projectile as it goes along the parabola, and that's called two-dimensional motion. Remember, we used to go one dimensions, either this way or this way. Now, two-dimensional motion. So each spot, I can divide it into horizontal and vertical motion. So when I did that, in orange is the horizontal, and the blue is the vertical. And amazing things happen because they act totally different from one another. So, Zach, tell me what happens to the X components all the way across.
It shrinks until it.
No, the X.
Oh,
X,
that just
X,
stays the
X.
same.
So that's the orange. What? Say it again.
X just stays the same.
It stays the same. It's the same length. If you drew the parabola correctly, I tried. If you could imagine, these are exactly the same all the way across. The velocity stays the same all the way across. So, what happens to the blue? Do you recall? I think you were here, Alex, for that. What's happening to the blue guys as we go across? The vertical component, which we call the Y component.
It goes up and then it goes down.
Right, it goes up, and as it goes up, what's happening to the
smaller.
size? What?
Smaller.
It shrinks, and then after the max height, it starts
Get bigger.
growing in the opposite direction as you indicated. All right, and some of it's still there, Alex. It's exciting. All right. All right, give me some numbers. Forget this theory. We want some numbers. So, Emily, number 1, what is always the acceleration in the Y direction?
-9.8.
Or,
32.
all right, so I'll put in negative 9.8. What is always, Emily, number 2, what is always the acceleration in the X direction?
0.
All right. All right, velocity initial in the Y direction, we're given a number here, velocity initial. What do? We have to tweak that. We can't just use V sub O. So what do we have to do, Brian, with this value when we're working in the Y direction?
We have to take that velocity and multiply it by the sine or
Right.
whatever angle
Right, very
we're
good.
shot at.
I should put in an angle there for emphasis. And then also,
It's real
Brian, what
small.
happens in the X direction?
Here, let me zoom in. In the X direction, well, you just multiply the velocity by the sine
Right.
of the angle.
All right. Now, did you say?
I mean the cosine of the angle,
that's
sorry.
right. You just use sine. All right, so X direction, the velocity involves the sine of the angle, and the Y is, now you got me doing it.
Sorry.
In the X direction, it's cosine, and the Y direction is sine. All right, the only other point that is the same in all is what's the velocity if you're cutting it off at the midpoint of the flight? So you're at the max height. What is the velocity in the Y direction final? Do you recall how that works, Emily,
would-
number 3?
Velocity of the Y
Yeah, the velocity, the final velocity, if we're cutting it off at the max point. So let me put that in. Velocity y at the max.
Oh, okay. The max is
Pardon?
0.
Yes, right. All right. So it seems like if you understood all of those pieces that are up there right now, you can do all of the problems. Those are the main highlights of what we learned.
What about the final velocity in
That's
x?
a new equation.
Wouldn't that be the range?
What's that?
Would that be the final velocity of x be the range?
Final velocity of x is going to actually be the same as the initial velocity
Oh, yeah.
and x because it stays the same.
Yeah,
So
that's
it
it.
doesn't come up too much in our problems. So it comes up and it's more of an aggravation than anything.
Okay.
All right, so here's what we did yesterday. You do not have to copy this down unless you have it, it will help you. So there's some holes you can help me fill in. This is the long way, this is the short way. So that's why I did the long way, so we can breeze through it rather quickly. So we have a projectile, it's a bullet, 41 meters per second at 52 degrees, and it's going to hit this target right here. We renamed the distance in the x direction, starts with an R. What is it, Emily, number 1? Range. All right, so now we have the range is the distance in the x direction. I'll switch to orange, just keep my color coding. Since I did x was orange. All right, so we'll call this the range. In our formula hits right here, this is the range, the distance in x in x. So that's what that means. All right, so we pull out our big 5, velocity, initial, final, acceleration, time, and distance, all in either x or y. When we're looking at a range problem, we're looking at an x value. So we start happily down this path until we hit a dead end. So here's velocity initial. I said it was going to use the cosine. So we have 41 cosine 52. It comes out to 25. And acceleration in the x direction, always 0. Time, we don't know. The range is what we're looking for. So I use this equation because the other ones failed me. And this one failed me too, but it didn't fail me as bad. So this bleeps out because acceleration is 0. So I have x equals 25 times t. Does not give me an answer. So what do I do with this problem when I have time unknown? Emily, number 3.
You find time by using y.
Right. We were trained, if you get stuck in x, jump over to y. What are we going to look for, Emily, when we get to the y side?
Time.
Yeah, we're going to look for time is what I'm trying to get you. So we're going over to y to find time, because can you see we can come back and put a number in there and get the range. So then we start down this, again, v sub o in the y direction, v sub y in the y direction, a in the y direction, t in the y direction, and x in the y direction. Here we know 41 sine 52, 0, negative 9.8. We're looking for time. We don't know how high it's going to go. We don't know the distance in the y direction. Brian, does that show up or is it blocked by some of the
Nope,
stuff on the table?
that works.
Even down to here?
Oh, down to here. Let's see. Nope, that's
It's still there?
It's still there.
Okay, very good. So
So I
we
was
end
taking
up
notes.
using this equation and plugging in these values, and we got time equals 3.3. Is that the time that will go back up here? Is it, Emily, number 2? What's wrong with that?
It's only to the halfway point. You have to multiply by
Right.
2.
This is to the max height, so we have to multiply it by 2. I think I forgot to do that yesterday, so I'm on a roll today. I've got it right. 6.6. So what is 25? Calculator's out because we need them anyway. 25 times
Holding it sideways, Brian.
6.6.
Yeah, it helps be able to focus on the left side of the board.
What's it? One what?
Thing I can't use the
All right,
tripod.
so I'll round that to 170 meters. All right, that's what we did one time yesterday. And then we took away all the numbers, and we actually did the same thing with all theory. with x's, v sub o's, thetas, and so forth. And we came up with what's just called the range equation. And the range equation is a summary of all of this work sitting right there in that one. So say, thank you, mathematicians.
Thank you, Mrs. Powell.
I'm not a mathematician.
Yes, you are.
Oh, thank you. That's sweet. All right, so let's do the same problem right here. 41 meters per second, 52 degrees. And let's find the range with this equation and see if we get the same answer, the 170, and just see if it works. So on your
Alright, I'm just gonna
papers
zoom out
now,
here.
go ahead and find the range. You can work on yesterday's paper, day whatever, 3 was it? Yeah, day 3. Do you have day 3? And do you have his day 3?
I'm writing it.
Okay, good. So, let me know if it comes out to 170. That's going to be rounded. Here's the problem, right here. I'm putting this information into this formula to see if we get this value.
When it says v sub o, does it mean v sub o x or v sub o
Good
y?
question. Very good question. When we're in this formula, it's even easier. It's just v sub o. It's just that. So you don't have this. So much simpler than all of this who struck. So also you'll remember G is positive in this formula. Did you come out?
I think we're just about out of time.
Okay, let's close it down then. All right, we'll reveal this exciting answer in a few. Go ahead.
All right.